linear expressions, and that's one of your objectives in Study Island, so you should be able to get through those. In order to do this, we need to review distributive property, which you learned middle of the year last year, so I'm sure it's really easy. Combining like terms you learned at the end of last year, and I want to refresh your memory on multiplication and division with integers only. With addition, we've been doing, I owe this much money, I have this much money. We haven't multiplied with integers since the beginning of the year, so I just want to remind you, and I'll leave it up here for you. Positive times a positive is a positive, negative times a positive is negative, and a negative times a negative is a positive. So put that back in your head. I'll leave it up here for now. I'm going to start talking to you about the distributive property because you need to know this in order to handle this. So I'm going to start real simple for you so your brains can grasp onto this. If you have an expression like this, you know that the order of operations tells you you need to do whatever inside the parentheses first and then do the multiplication afterwards. Our problem is that I can't do x minus 3 because I don't know what x equals. So the only thing I can do until somebody tells me what x is simplify it. So there's a couple of ways. I talked to you last lesson about you guys being puppet masters when it came to math, and so I'm just going to show you one of the puppet master moves you can do, 2 puppet master moves, and it's using the distributive property. Okay. So this is 5 times everything that's in here. So I can go ahead and still do that. I can go 5 times x, which is 5x. Everybody comfortable with that? And remember earlier I had mentioned to you guys that we want to stop looking at this as add or subtract and instead look at it as the positive or negativeness of the next item. So this is a negative 3. So I have a positive 5 times a negative 3. Positive times a negative is a negative. So put negative, and 5 times 3 is 15. You see that? I saw the look on your face like, I'm not sure, and then wait a minute, now I'm sure. So it was 5 times x, 5x, 5 times negative 3, negative 15, okay? That is distributing in. Because sometimes I need this to look like this, and sometimes I need this to look like this. So if I told you to simplify that, and you distributed in, that's the answer. You can't do anything else other than that, bless you. You can't do anything else other than that until you know what x is. You're stuck, and that's enough, okay? You can also, sometimes you don't want it looking like this. You want it looking like this. So you can distribute out. And you do this very similar to the way you reduce fractions. Think of how you reduce fractions. You're always looking for numbers that go into both. Is there a number that goes into both 5 and also 15? What number? 5. 5. You're thinking 5 times 3 is 15. But 5 goes into both of them. I knew you were thinking. 5 goes into both of them, so we can pull 5 out of it. So if we pull 5 out, 5 goes into 5 one time, so I have 1x, and 5 divides into negative 15, negative 3 times, and here I am back at that. So this is much like your skills for reducing fractions. If you see a number that goes into both of them, you can pull it out so that you have it simplified. So you can distribute in when you need to, or you can distribute out when you need to. Make a little bit of sense, sort of? Okay, good. So now that we've done distributive property, we're going to just refresh your memory on combining like terms. This is a real simple one for you. You've seen terms like 3x, that's a term, and let's say 5x, that's a term. These are like terms because they have the same variable to the same exponent level. So I could put these together because they're like terms. It's a positive 3x's and a positive 5x's is a total of 8x's, right? Okay. If it looked like this, though, x to the second power.
Then I'm going to be 3 times 2, so that'll be 6x.
No.
It's good thinking, but this is actually 3 times x
9
times x.
Oh.
And I don't know what x is, so I'm really kind of stuck. What I just want you to recognize right now is that this is not the same term as that. I can't combine these terms, they're not like terms, okay? So not like terms. Here's another example of not like terms. They're different letters. I can't combine those, they're not like terms, okay? These, though, are the same term. They're simply numerals, and so they can be combined. They're a like term. So like terms, right? Not like terms. I know you're thinking, OMG, this is way too difficult, but just like Franny said, waffle bites, little bites at a time. And we're going to use the distributive property and combining like terms to solve this one at a time. This is really meaning multiply anything times what's in here. There's nothing in front of it, it's all positive. So this is all positive times positive, it's not going to change anything. So go ahead and write down this stuff without the parentheses and just drop it straight down. And that one is that easy. It's when you get over here that it changes up a little bit. Because this is a negative times everything in here. So I'm going to use that distributive property and multiply that negative into everything. So I have a negative, you can remember how we had the x's and we all understand that that's the same as 1x.
Yeah.
Or a negative x, that's the same as negative 1x. Same idea going right here. This is like a negative 1 being multiplied and being distributed in. So a negative 1 times 3. It's a negative times a positive, which is?
Negative.
Negative times positive, which is a negative, right? And 1 times 3 is 3. And then it's a negative 1 times a positive 5. A negative times a positive is a? Negative, so put negative. And 1 times 5 is 5.
Why?
Okay? Once that distribution is done, you go on to combining like terms. There's positive 5x's, and what's his like term in here?
Negative 3x.
This negative 3x. So I have positive 5 and I have negative 3 that I'm putting together. I have 5, but I owe 3 x's. I'm going to have positive 2 x's left. Yes?
Yes.
Okay? My other like term is what?
Negative 2y.
Negative 2y and negative 5y.
Then you bring down what you did.
I owe 2 y's. I owe 5 more y's.
7y.
Seven.
There you go. Negative 7y.
Oh yeah, what's it?
And notice I'm using that negative as that sign that I talked about. That is as far as you can go. That's your answer. So if you were to get a question like this on Study Island in linear expressions, this would be the answer. That's all.
Because then you can't get more because that's not a like term.
Right. They're not like terms, so you can't do anything else.
What did you do with 2y? And 5y?
Here, this was a negative 2y and a negative 5y, and I put them together. I owe 2y, and then I owe 5 more y, right? So that's negative 7y. I owe you.
Oh.
Yeah. This is where it gets this tough part. This is all addition going on with negative numbers. So think owe money, have money. This up here was using this multiplication. So that's the hardest part of integers, is knowing the different rules. This is multiplication and division only. But when we went into adding those integers up, that's back to I owe money, I have money. Okay? All right. Previous one, that was like me lifting you. Take all the way back. I'm going to take you all the way back to when you were a baby and you were just learning to walk.
What?
You were just learning to walk. And on the previous one, I would pick you up and you would kind of wobble there, and I held on to you while you walked on the previous one, right? This one, because at some point, the people who helped you learn to walk, they'd pick you up and they'd let go and see how you did. And sometimes you'd wobble there and fall. Sometimes you'd get one step in and fall. Sometimes you'd get 2 or 3 and fall. And this is where we're at here. This is me lifting you up and letting you try it. So this one, so you've only seen one like this. So you're not good at this. You're just not. You're going to try though and see how far you make it. Can you take the first step, or do you fall right away? And that's okay if you fall right away, because in a moment, after I give you a chance to work on it, I'm going to pick you up and help you through. So go ahead and try this, and let's see how far you make it. Everybody made it to a different point because that's how it works for us. So let's find out exactly what happened and where we stumbled at. This is positive, so it's going to be the same all the way through. This, I'm going to distribute this negative through. This is a negative times a negative, which is a positive
Oh.
2x. This is a negative times a positive, which is a negative 5. Now, I'm combining like terms. Bree has a question. Okay, let me back up. Lost me right there and she spoke up like she's supposed to. Thank you, Bree. This is negative 1. Are you okay with this being negative 1 here? Okay. I'm doing negative 1 times negative 2. What's a negative times a negative? Positive. And 1 times 2 is 2. So I need this to be a positive 2x. So I put positive 2x there. Good there? Nice. And then I do negative 1 times positive 5. Negative times a positive is a negative, so I put negative 5y. Good now? Fantastic. Thank you for stopping me and making me explain that. All right. Now I'm on my like terms. Positive 8x put together with a positive 2x. How many x's are there?
2.
10x.
Positive
10x.
10x. Did we all see how she got that?
Yes.
And then you
We
all
added
add
them together.
together. Then you have 3
Plus negative 8x.
Overwhelmed. All right, positive 3y and negative 5y. Positive 3 and negative 5. Think of money, or just think of which of these absolute values is bigger.
The 5.
The 5. I have more negatives than I do positives, right?
Yes.
So whatever I have, it's going to be negative. Then find out the difference between them. 3 or 5.
2.
2 is the
So,
difference.
Negative
between them.
2.
So negative 2y.
Yeah.
That's your answer.